solve those problems, like getting the cross-price elasticity of demand between fuel and labor, the production function has to be behaved in a certain way. It has to have certain properties. Namely, it has to be concave, and the second derivatives, both own and cross derivatives, have to behave in a certain way. So when I say to be well behaved, this must be homogeneous in prices. So there are certain restrictions on what the coefficients can be in order to know that that this is a good approximation to a well-behaved underlying production technology. So when we say that isoquants are downward sloping and that the production function is concave and the isoquants are quasi-concave and blah, 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 all that mumbo-jumbo that you got from the moment. So that when I say it's well-behaved, I mean to say that the isoquants are quasi-concave, that the production function is strictly concave, and so on and so forth. And if the production function has all those attributes, then it must be the case that the sum of the alpha I, alpha 1, alpha 2, alpha 3, alpha 4, adds to 1. That's the first restriction for homogeneity in prices. Additionally, the sum of the gamma ij, so every place you see a gamma with a double numerical subscript, gamma 1, 1, plus gamma 2, 2, plus gamma 3, 3, plus gamma 4, 4, plus gamma 1, 2, plus gamma 1, 3, plus gamma 1, 4, plus gamma 2, 3, plus gamma 3, 4, plus gamma 2, 4. That sum has to be 0. Additionally, gamma yy plus gamma ky plus gamma fy plus gamma ly plus gamma my also have to add to 0. Oh, there was a question about what's y and what's m. Y is output. If I was really paying attention, I would have made sure that I used the same symbol in the data as I used here. So y and q are the same thing. They're both output. C is cost. PF is the price of fuel. PK is the price of K. PL is the price of labor. PM is the price of materials. Well, then you have KFLM. So capital, fuel, labor, materials. 4 inputs. Now, the question is, why did I give you the data for only 3 of the inputs? Well, the picture I have on the board, I have only 2 inputs. If you know F star, you know L star? Yeah, you have to. So if you have 4 inputs, you're only free to choose 3 of them, because knowing 3 of them tells you what the 4th must have been. So there's a singularity in the first order conditions. Knowing the solution to 3 of them tells you what the solution had to be to the 4th. So I only needed to give you data for 3 of them. Because having figured out because of the restriction, the homogeneity restriction, if you have estimates of the coefficients on everything but materials, which I didn't give you, you can figure out the materials coefficient by imposing the restriction, by solving the restriction when one didn't estimate correct. But indirectly, you can get the materials coefficient. So, and incidentally, I don't know if you've been looking at it long enough to have noticed, gamma 1, 1 is multiplying the log of pk, the quantity squared. So 1 corresponds to capital. Gamma 2, 2 multiplies fuel price. So 2 must correspond to fuel. 3, 3, well, that must correspond to labor. And 4, 4 must correspond to material. So then when you come to gamma 1, 2, we already decided that the index 1 corresponded to capital and 2 corresponded to labor. So that was the subscripting choice for the gamma that sits in front of pk, pf. Okay, so there's a mapping from the index numbers to the letters. Yes? Right. Exactly. Yeah. First order for k is just alpha 1. So alpha 1 would be the derivative of alpha 1 would be the derivative of the true cost frontier with respect to pk in log form. And so, for example, gamma 1, 3, the second derivative with respect to K and L. So the individual Greek characters are the partial derivative of the factor price frontier, and that's what we're estimating. So, to be well behaved, this must be homogeneous in prices given Y. This implies the following restrictions. So these things are supposed to be true. And, to repeat it, you don't have data on materials because you don't need it. Because at the solution, if you know 3 of the optimal choices, you must know the 4th. So it's unnecessary to have the 4th. Okay?
But the lambdas?
What?
Next, the lambda, the double summation.
Oh, my finger must 100 across. That's supposed to be a gamma.
Gamma.
Right. Optics then. Okay, so this is, Nick has pointed out to us that this character is supposed to be a gamma ij. A function of two or more arguments is homothetic if all ratios of its first partial derivative depend only on the ratios of the arguments, not on their levels. For competitive consumers or producers, optimizing subject to homothetic utility or production functions. This means that ratios of goods demanded depend only on relative prices, not on income or scale. What restrictions would be necessary for the cost function to be homothetic? As a practical matter, and to help you understand it, a function is homothetic if, in this case, as you increase cost, your optimal choices lay on a ray out of the origin. So that at your optimal choices, the marginal rate of technical substitution is always the same, regardless of the scale that you have picked. Whether you're producing a little or a lot, your optimal choice is going to be such that the marginal rate of technical substitution, optimal choices all lay on a ray through the origin. As opposed to, say, an example where as opposed to this kind of example, where there's no way you can get a ray through the origin to pass through those two optimal choices. This, by the way, is important when the subject of gross substitutes and net substitutes comes up. This is one of the things that I learned from George Lady in the last couple of years. It comes up in applications of the Le Chatelier principle. The Le Chatelier principle basically tells you that he and I wrote a paper about falsifying economic models, and we've talked many times about this Le Chatelier principle and whether or not capital and labor, for example, can be something other than gross substitutes, or if they're gross substitutes, can you think of a counterexample where it's impossible to have that situation, basically, as opposed to the one on the right. Okay, so the Le Chatelier principle tells us that if things are well behaved, the solutions have to work out this way. If the technologies are not well behaved, they can work out that way. And so the question is, what are the circumstances under which that happens? What restrictions would be necessary for the cost function to be homothetic? So you need to look at the first order conditions and construct the ratio of, say, the first order condition for capital and the first order condition for labor, and see whether what you have to do to that, to the unknowns, the gammas and the alphas, what restrictions do you have to impose on the gammas and the alphas so that ratio is always the same. One valuable hint, by the way, is that if it's homothetic, then the ratio of the demand for labor to demand for fuel doesn't change with the scale. That's a hint. You might want to write that down so that when you're working on that question, you can read that and say, what do you mean by that? What? Did I repeat that? Yeah, the marginal rate of technical well, here, the marginal rate of technical substitution is the same as here, because the price ratio is the same. Okay. But L0 to F0 doesn't lie on the same ray as L1 to F1. That's the difference. So here, the ratio is always the same, regardless of what Q is. The one on the left, that's not true. If it's homothetic,
it's the right.
Homothetic is the one on the right.
Yeah.
Right. Homothetic is the one on the right. So you can see that the ratio of L to F does not change with the scale of output. So you can ask yourself, what restrictions do I have to impose on the ratio of a pair of first order conditions to make that happen?
Is that called on the left?
Non-homothetic.
Well, or heterothetic, or
no?
No.
Non-homothetic.
Non.
Could you repeat what Le Chatelier's principle was?
Le Chatelier? It's better just to look it up in what do you call it? Wikipedia. Okay, so everybody's straight for A. You have some sense of what I'm after.